Hey guys, I'm going to be talking about how to solve a right triangle today. I am on page 21 in your yellow notebook if you would like to follow along, or you can also print the documents that are on Canvas, and that's an option for you too. So before we get into actual example problems, I do want to mention what solving a right triangle means. Okay, so when I ask you to solve a right triangle, it means that you want to find the lengths of all three of the sides and the measure of all three of the angles. Okay, so you need to find all three angles, all three sides. Now there are a few different options that you can do for this. You can use Pythagorean theorem, which if you don't remember it is a squared plus b squared equals c squared. This is great when you're given two sides. So for instance, you see how A, there's only one side length here, but B, we have two sides. So we could potentially use Pythagorean theorem to help us solve for the other angle. We can use trig ratios, which is our SOHCAHTOA. Okay, so kind of using our previous note page. And we can also use our inverse trig ratios, which we haven't really covered much of today, but I'll kind of go over that in depth and show you how you can use that. So first thing we're going to do is I'm going to look at these problems, and I am going to just kind of let you know that I'm probably only going to do about 3 of them to keep this note page short. So I'm going to show you how you would do one when given 2 side lengths to start. So I'm going to start with B. And then the one that's similar to B is D and F. So D and F both are similar to B because you see you have 2 side lengths for D and you have 2 side lengths for F. I'll move this one up a little bit. So I'm not planning on doing these 2, so just know if you are interested you can go ahead and do these ones on your own. I will let you know that they are very, very similar to B, okay? And then what's going to happen as well is I'm going to show you how to do A, because A only has 1 side length, and then I'm also going to show you how to do C. And the reason why I'm doing both of these is because of the fact that on A, it's a 30, 60, 90 triangle, which is a special right triangle that we're going to be talking about in our next notes. But C is not a special right triangle because it has this 56 degree and a 90 degree angle there. So although you can still do similar steps to A, it does take a little bit more time, okay? So let's go ahead and start with B. So if we want to find AB, which is the missing side, we're going to use Pythagorean theorem. So we're going to say A squared plus B squared equals C squared. So our A here is 6. Our B is 7, and our C we don't know, okay? Now, one question that my students always typically ask me is they say, Ms. Strickland, does it have to, like, does it matter what A is, what B is, what C is? And it doesn't necessarily. C should always be the hypotenuse, okay? So remember the hypotenuse is going to be across from the 90 degree angle, okay? So for instance, if you looked at D, the value of 6 would have to be your C, okay? Now 3, you could choose as A or B, it doesn't matter on that one, but the hypotenuse always has to be C, so just kind of make a note of that, okay? So we're going to go ahead and add 36 plus 49, and that's going to give us 85, and then to get out of the exponent, we're going to square root both sides. Okay, and so that's going to be C. Now if you wanted to, you could approximate this, and you could actually do the square root of 85. That's going to be about 9.2, so if you wanted to, you could either leave it as a radical or you could put it as a decimal. Okay, so that is the missing side. Now, to solve a right triangle, we also have to find all of the angles. So we know that angle C is 90 degrees, but we don't know what angle A or angle B is, okay? So what you can do is you can use inverse trig ratios to help you find these. So let me explain what inverse trig ratios are. So inverse trig ratios basically have you figure out an angle. So for instance, let's figure out angle A. So if I want to figure out angle A, okay, so this is B where my first theta is. It's going to take my values on my sides, and I'm going to create a trig equation for this. Okay, so for instance, let's say I use 7 and 6. So 7 is my opposite, and 6 is my adjacent. So opposite over adjacent is tangent. So I could say the tangent of 7 over 6 would be equivalent to my angle. Okay? So if I did tangent of 7 divided by 6, I'm going to get this really long decimal. And you're going to say, okay, that can't be right. So it's going to be 0.02036, right? So to figure out the actual angle, we're going to now use the inverse sign. So I don't know if you guys remember this, but inverse is basically taking it to the negative first power. So you can either put the decimal in, or to better approximate it, you put it as 7 over 6. So if I hit the second key, it will get me to do that. And I will get 49.398 or 0.4. Okay, so this is a way for us to use inverse trig ratios to figure out angle measurements. So again, if we just did it as tangent 7 over 6, we're going to get this decimal here, and that's not going to make any sense for our angles. So we're going to say angle A is going to be equal to 49.4 degrees. Now for angle B, you could do the same thing that I just did, or you can remember that all 3 angles of a triangle add to be 180 degrees. So I know that 49.4 plus 90 plus angle B would equal 180, okay? So if I added 49.4 plus 90, I'm going to get 139.4. And then I can take 180 and minus 139.4 to give me 40.6. Okay, so we've now solved appropriately our triangle B because we found the side length for C. Okay, so that's this one, AB right here. Okay, we've found the angle for A, which is right here. And then we found the angle for B, which is right here. Okay, so by using Pythagorean theorem and inverse trig ratios, we were able to successfully do that. Okay. Now, to help us solve the other 2 problems, we can either use our special right triangle knowledge, if you remember that from Integrated 2, or you can use our regular trig ratios. Now, before we get into our regular trig ratios, I am going to show you how to find angle A. It's the same steps that we did up here. So if we know that this is 90 degrees and we know that this is 56, I can say 90 degrees plus 56 plus angle A is equal to 180. So I know I have 146 degrees plus A is equal to 180. So therefore, angle A will be equal to 34 degrees. So we can figure out that angle pretty much by just knowing that all 3 angles of a triangle add up to be 180 degrees. Okay? And then from there, we can use our regular trig ratios to find our other sides. So what I mean by that is if we are looking for, let's say, CB here, okay, if we use 56 degrees as our angle, we have 16.3 as being our opposite and X as being our adjacent to 56 degrees, right? So 16.3 is our opposite and X is our adjacent. So we could do the tangent of 56 is equal to our opposite side divided by our adjacent side. And we can solve using our proportions here by cross multiplying. And then dividing. Oops, I'm running out of room here. Sorry, guys. So I'm going to go ahead and put that in my calculator right now. And so I get 10.99. I'm just going to round up to 11 here. Okay, so what this means is this side is equal to 11. So CB is equal to 11. okay? And then to find AB, we can either go back to Pythagorean theorem if we want, which I am going to do, or we can go ahead and do the same thing with our 56 degrees, but we would now use our opposite in our hypotenuse. So we'd say the sine of 56 is equal to 16.3 over hypotenuse. So for me, I'm going to go ahead and use Pythagorean theorem. So I'm going to say, okay, 11 squared plus 16.3 squared is equal to c squared. So 121 plus 265.69 and then we can square root that. Oops. Will be equal to c. Hold on just a minute. Replug it into my calculator. Here we go. So 19.66 is equal to C about. Okay, so we know that this value here, which I'm going to label as C, is my side. So again, let's just kind of go ahead and go through everything again. So we found our angle A by using the values of that all three triangles or all three angles add up to be 180 degrees. We figured out our value of CB by using regular trig ratios, and then we figured out the value of AB by using our Pythagorean theorem, which you could do that or you could use the trig ratios as again like we did on the second half. So you can see that there is quite a few options here, and I think that's where students get really struggle with or really have a hard time with, is the fact that there are multiple ways to solve a right triangle. Just know that you can kind of use, pick and choose whatever you guys want to do, and then that's going to be successful for you. Really quickly, I'm going to do A, and A might not make a lot of sense to you because we haven't done our special right triangles, but I do want to show you the ease that is for each one of these. So first of all, if I did 90 plus 30, I'd have 120, so angle B is going to be equal to 60 degrees. Okay, so I don't really have to do much math there. Now, when we're doing a 30, 60, 90 triangle, this is equal to a radical, a radical 3. Okay, this is our A, and this is equal to 2A. So what that means is that these are our ratios that we're going to be using, and again, they might not make a lot of sense to you, but because we have this side given, 2 is equal to 2A, we could solve for A, and A would be equal to 1. So we know that this side will be 1. And then this side, since A is equal to 1, it's going to be 1 radical 3, so we know that AC will equal just radical 3. And so by knowing the values of our special right triangles, you can see that it takes off a lot of our work, like meaning that we don't have to do all of this work by just knowing what our special right triangles are. And so that's going to be, I'm going to tell you kind of that's the benefit of knowing special right triangles, okay? So we're not going to do the rest of the problems on this page, and I am going to stop this note page and continue the back side of the note page on the other side. So thanks so much for hanging out with me today.